This is Dr. Manjunath Channapugod from Anveshana Academy, Bangalore, India. Dear students, we are discussing numericals on Carnot Cycle. Today also I am going to solve some numerical on Carnot Cycle. So numerical on Carnot engine. Okay, so this is our third numerical we are going to do. I am going to do on Carnot cycle. Okay, so what is the third numerical? What is the third numerical that you can see here now? So a Carnot cycle operates between source and sink temperature of 250 degrees Celsius and minus 15 degrees Celsius. If the system receives 19 kilojoules from the source, find efficiency of the system, the net work transfer, third one heat rejected to sink. So now it is what the problem is related to Carnot cycle that you have to mark one thing, and it operates between two sources here now. Okay, two sources, one is heat source, another one is sink. The temperature of heat source and heat sink he has given 250 degrees Celsius and minus 50 degree Celsius. If it's so, the minus degree Celsius, if the system receives 19 kilojoules from the source, then what is the efficiency of the system? What is the net work transfer? How much amount of heat is getting rejected to the sink? That you need to calculate. To calculate that, how to do that? That you can see here now, dear students. First one, as I told, draw the rough diagram for your understanding. As he told, there are two sources. One is heat source, another one is heat sink. Okay, the temperature at heat sink or heat source he has given, that we can mark it as a T1. T1 is called to how much he has given? He has given 250 degrees Celsius he has given. Convert the degree Celsius into Kelvin by adding 273. So therefore T1 is equal to 250 plus 273. It becomes what? 523 Kelvin. Hence, so source temperature is 523 Kelvin. Fine. Then T2, the temperature at heat sink. That heat sink is nothing but what? Freezer here now, because the temperature of the heat sink is minus 15 degrees Celsius. Hence we can call it as a freezer. What is the temperature of that heat sink? The temperature of heat sink is represented as a T2. So what is T2? T2 is equal to minus 15 plus 273. It becomes 258 Kelvin. So therefore temperature at freezer side as sink side is T2 is equal to 258 Kelvin. Fine. Then amount of heat received by the system. That means what? You can call it as a system. That how much amount of heat is received? You can call it as a Q1 or a Q2. How much? That is 90 kilojoules of heat is supplied to the system or received by the system. That he has given in the problem itself. Fine. So with the help of this given data, what we need to calculate? We need to calculate first parameter is efficiency of the system. So then what is the efficiency of the system now? It is a Carnot engine, right? We know the equation efficiency of the Carnot engine. That is what? 1 minus T2 divided by T1. Okay, what is the higher temperature here now? T1. What is the lowest temperature? That is a T2. So therefore what I can do now? Carnot efficiency is equal to 1 minus T2 divided by T1. Okay, what is 1 minus? Then T2 he has already given, that is 258 lower temperature. Then higher temperature is 523 Kelvin. The do simplification, you will get 0.506. That is nothing but what? 50%. So efficiency of the Carnot engine is 50%. So therefore what I can say, the efficiency of the Carnot engine is 50%. That is the first one. Second one, net work done. How to calculate the net work done in the Carnot engine? In the Carnot, 1 minute. In the Carnot cycle, how to calculate work done? So we know efficiency is equal to, generally we know efficiency is equal to work done to heat supplied. Okay, heat supplied, we can take it as a Q1 here now. So how to calculate the work done here now? Now work transfer, how to calculate now? So therefore I can modify this equation. How I can modify this equation? Capital W is equal to neta or neta C into heat supplied, that is Q1. So therefore work done is equal to Carnot efficiency multiplied with heat supplied, because we know Carnot efficiency is nothing but what? It is the ratio of work done to the heat supplied. So therefore what I can do here now, Carnot efficiency is already calculated, that is 50.6, that is nothing but what? 0.506 into heat supplied is 90 kilojoules, he has given already, multiply, you will get answer in terms of what? Kilojoules only. That means what? Total work done or net work done is equal to 45.54 kilojoules. So you can mark it down. This is what work done. That is a second parameter is done. The rate of work transfer we done. The third point is heat rejected. How to calculate heat rejected? Dear students, already we know the equation. So it's a simple one. When it comes to work done, we know work done is equal to what? Q1 minus Q2. According to first law of thermodynamics, net work transfer is nothing but what? Q1 minus Q2. But I don't know the value of Q2 here now. But you know the value of work done, that is W. You know the value of W. With the help of these two data, what I can do? I can calculate the third one, that is Q2. So therefore Q2 is equal to W minus Q1. This is minus. Okay, then what we can do here now? So therefore QW is equal to Q1 minus Q2. So substitute here now. Substitute. What is, so W is equal to Q2 is equal to, okay, what is Q2? Q2 is equal to Q1. That minus sign indicates what? Heat rejected. That we'll see it later. Q2 is equal to Q1 minus W. So Q1 is equal to 90 kilojoules. Work done is 45.54. Then you are going to get 44.46. So therefore Q2 is equal to, you can see work done we know already, Q1 minus Q2. With the help of this equation, capital W is equal to what I can do? 90 minus 45.4. Then I am going to get 44.46 kilojoules. So therefore heat rejected to the sink is 44.46 kilojoules, dear students. Okay, fine. So now, so what all the things you have done? You converted temperatures in Kelvin, calculated the efficiency, then express that efficiency in terms of percentage, then you calculated the work done, then you calculated the heat rejection. Once you've done all the things, then try to list out the answer in a tabular column at the last. How it is, that you can see here now. What is the work done? 45.603 kilojoules. What is the temperature? Two important source temperature. What are those? 215, 523 Kelvin. Sink as well as heat source. How much heat is rejected? 44.397 kilojoules. What is the sink temperature? Minus 59, that is in minus 15 degrees Celsius, and that is about 258 Kelvin. Efficiency of the current efficiency is 50.67%. The heat received or heat supplied to the engine is 90 kilojoules. This is what Carnot cycle or Carnot engine we can call, dear students. Okay, so now you did the step 1, you converted all the things, then you used efficiency formula to calculate the Q1 and Q2 W, then you calculated the work done, then you calculated the heat rejected. The calculated value we have tabulated at the last as a answer. So this is the third numericals how you solved. I hope you understood this problem, dear students. Please here with I request you, please do subscribe my channel, like, comment and support me. Thank you.